Graphing velocity practice worksheet. Okay. So the first one we're going to do, look at this first section here. It says draw a distance versus time graph for the data table below and choose the correct description of the motion of the object. So we have a data table here. Time in seconds, distance in meters. And here's our data that's we've recorded. Here's the space where we're going to create the graph, and here's the description. So let's first plot our data. So to help kind of orient ourselves, right? So we have time here and time on our x-axis. And we have distance, it's going to be on our y-axis, okay? Also, for a little bit of orientation as well, it might be helpful to identify here where we have our reference point. It's a little hard to tell in this graph. It's the lighter colored line in the graph, okay? So that is worth emphasizing right there, making it darker just for the video so you guys can see what I'm pointing out there. So that right there, where distance is equal to 0, that is our reference point. Okay, so our first, the way we take this as we have to plot points. So we have a plotted point at time 0, distance of 8. All right, so time here is 7, 6, 5, 4, 3, 2, 1, 0, and a distance of 8 meters is going to be right there. So we have a plotted point right here. All right, our next point is at 6, time of 1 second, a distance of 6. Our next point is a time of 2 seconds, distance of 4. Next is 3 seconds, distance of 2. The next is 4 seconds, distance 0, so that one's right on the reference point. And then we have 5 seconds, negative 2 distance, and it's 6 seconds, negative 4 distance. Okay, once we have all those points plotted, we're just going to connect the dots, and if you look at that carefully, you will see that we have a straight line, and we connect the dots, we get a nice linear graph. All right, now let's look at the description of the motion. We have, is it moving at a constant speed away from the reference point? Well, this is representing the object, and this is the reference point. As time passes, it's actually getting closer to the reference point. So it's not going to be A. B, moving at a constant acceleration away from the reference point. Well, we haven't discussed much about acceleration yet, but constant velocity on a distance displacement versus time graph is a linear line, and acceleration is nonlinear, so it's not going to be that one. All right, moving at a constant speed towards the reference point, and then it says past the reference point. Right there, it's passing the reference point and keeps going is this piece right here. So the description of the motion for that one is going to be C. D, it says moving at a constant speed towards the reference point, but it doesn't mention the passing it. So this one is a better answer, C. The next section, all right. With this one, you have here 6 graphs, 6 displacement versus time graphs, and 8 descriptions. You need to find which description matches which graph and just write the letter on there. Okay? I'm going to do the first one with you, and then I encourage you to pause and then work out the others. And then just check your answers. For the first graph, to identify to which graph it is, let's pay attention to where it starts. So right there, that is a negative position because it's below, on the y-axis, it's below the reference point, so it's a negative position. So we need to find all the descriptions that say it starts at a negative position. Starting mean the time is 0. So starting a negative position is A and H. Okay? From there, all right, this piece of the graph right here, that is moving in the positive direction, because it's a positive slope. It's also moving towards the reference point, which is the reference point right there. Okay? And so let's look at these two. One says moving fast away from the reference point, and this one says move towards the reference point. Well, the only one that matches that is moving towards the reference point. Okay? So we know it's probably H, but let's just confirm. Okay? And then next it says past the reference point. Right here is that moment where it passes the reference point. And then it says keep moving for a moment. So it just keeps going. There we go. Just keeps going. That section of the graph. All right? And then stop in a positive position for a few moments. That's this. Horizontal and displacement versus time graph means something is stopped, and that's a positive position because it's above the reference point. Okay? And then it says return. Okay? return to the reference point. That's this last segment right there I have in yellow, returning to the reference point, because that's right there, the reference point. So that graph we see right there. So starting in a negative position, in pink moving towards the reference point, the dot in blue is passing the reference point, the section of purple keep moving for a moment, our section in orange is stopped in a positive position for a few moments, and yellow return to the reference point. So this graph description is H. Now I want you to pause and try to figure this out on your own. Okay, working through the rest of these. Here we go. All right, so let's look at this one. Starting in a positive position. So positive position, our options are C or E or D. Positive positions. Okay, starting in positive positions. So after that positive position, right there we have a positive slope or moving away from the reference point. Notice it's a very gradual slope, so that object is moving slowly. So find that description. Okay? So moving slowly away from the reference point. So moving, this is a medium speed toward the reference point, so it's not C. Moving slowly in a positive direction. Okay, yes, moving slowly in a positive direction. And let's check C. Moving away from the reference point in a negative direction. Well, that's not it. It's positive. So here we go. Moving slowly in a positive direction. That's this piece of the graph right there. And then it says move very fast toward the reference point. Okay. And then this moment right here, past the reference point. That's that spot right there. And then it says keep moving. All right. So that's this section right there. And then our last section, suddenly stop and stay at rest. That would be the suddenly stop and stay at rest. Okay, next one. So that one is graph. That graph is description E. All right, next we are starting at the reference point. So starting at the reference point, we're either dealing with F or B or G. Okay, starting at the reference point. And then from starting at the reference point, that's super steep. That means it's going really fast. And you can say it's either going in the positive direction or it's moving away from the reference point. Both of those are correct in this piece right here. So positive direction or away from the reference point, very fast. So reference point at rest, not that one. Reference point negative direction, nope. Here we go. Moving very fast in a positive direction. So there we go, very fast in a positive direction. And then suddenly change direction and move very fast. Suddenly change direction and move very fast toward the reference point. Okay? That's this piece right there. Move very fast towards the reference point. Okay? Before reaching the reference point, change direction. That's that spot right there. Before reaching the reference point, change direction. And then our last section, move slowly away from the reference point. So slowly, notice it's a much more gradual slope there. So there you go, moving very slowly away from the reference point. So that matches graph G. All right, next one. We are starting in a positive position. So that gives us C or D. All right, and then from after that, from that positive position, we are moving in the negative direction or towards the reference point. Both of those are correct. You can say it's either moving towards the reference point in a negative direction. So this one says moving away from the reference point, and this one says medium speed towards the reference point. So here we go, moving at a medium speed towards the reference point. And then it says stop at the reference point for a few moments. So that's this section right here. Stopped at the reference point, horizontal along the reference point for a few moments. And then we are going to continue in the same direction with the same speed. That's that section right there. Okay, so that matches graph C. Okay, description C for that graph. Next one, it is starting in a negative position because it's below the reference point. So starting in a negative position, the only one left is that is A. All right, so let's just make sure the rest of it fits. From there, you're going to move very fast away from the reference point. Yes, that is moving fast away. Steep line, so that's fast, moving away from the reference point, getting further and further and further from the reference point. All right, and then it says, away from the reference point. And it says turn around, which is that spot right there, and then move slower back to the reference point. So this slope is less steep than that one, so it's simply slower. This is slower than that. Less steep, this is more steep. So this one's faster, this one's slower. And then back to the reference point, which is right there. So to the reference point. Okay, so that one matches description A. The last one, we are starting at the reference point. So we have two options here. All right, right here, this section, this first section right here, that motion is that graph is horizontal there, so that means it's at rest. So here we go, at rest. And then it says you want to slowly move in the positive direction. So this is a very gradual slope, positive gradual slope. So positive direction. And next, it now increases speed, a steeper slope, and continue in the same direction, so it's still positive slope. So that one matches description B. All right. Backside. This top section is matching the data tables to the graphs. So we have 4 graphs, we have 5 data tables, and match them, okay? So this is my check to see if you can, if you know how to plot points and you can read it. So you have an idea what the graph will look like. So since we have more data tables and graphs, let's start with the graphs. Okay, I'll do the first one with you and then we'll have you pause and attempt the rest on your own. So right here, starting in a positive position. So we need to have that first point being a positive number. So it's not going to be A, position, it's not going to be A. All right, position, positive 10, yes. Positive 5, yes. 0, no. That's reference point, positive 5. So it can be one of these 3, okay? So all of those are starting at time 0, a positive position, okay? Now, this right here, the position, the displacement is going to increase. We need a bigger number for the next number. So right here, this one decreased, so it can't be that one. But these both increased. So it could be this one or it could be that one. Okay? And then after that, our numbers decrease quite a bit and quite quickly. All right? So from there, a decrease. This one, it stays the same. This one decreased. So here we go. A decrease. So to right there, the negative 5. And then that constant negative 5 is what we're looking at there. So this graph, the data table for it is data table E. All right, pause the video at this time and attempt to finish this section on your own. Believe me, you need to practice doing it. If you're just watching the video and recording the answers, you're not going to learn anything. So please pause and attempt to do it. And just watch the video to check your answers. All right, so our next one. Right here, we are starting at the reference point. Okay, so starting at the reference point means at time 0, your distance is 0 or position 0. So there we go, starting at the reference point. That's the only one that starts at the reference point. All right, then from there, a really big increase. So 10, definitely much greater distance there, much greater position. And then a decrease at 5. Okay, so now that's 0.5 right there. And then it increases again. Okay, so the 7, and then the 9, and then the 11, the numbers just keep going up. Okay, so that data matches graph, the data table D for that graph. Okay, next one, we are starting in a negative position. So we must have a negative position, negative displacement. So negative, this one starts in the negative at time 0. and then it goes positive. All right? So now we have a positive 5, that's right there. And then we have another positive 5. Okay? It's staying at a position of 5. It's at rest. All right? And it stays at rest and continues at rest. All right, continues at rest. And then our last data point goes all the way back to 0. So returns to the reference point there at the very end. So that data table and graph match. So this is the data table A. All right, last, starting in a positive position. All right, positive position. So these two that are left, we're starting in a positive position. And then the numbers decrease. So a decrease would be this one. Right here we have a decrease in numbers. Okay, so it goes to a 5. And then it decreased to 0. So right there, time 2 seconds, it's at a 0 position. And then it stays at that 0. Okay. And then at the next second we have a negative 5, so now decreasing even more. So over here we got negative 5, and then below that we're going to have the negative 10, even further down. So negative 10 in yellow. So this data table, this is B. All right, next section. Roaming the halls. I highly encourage you to attempt this section on your own. Do the best you can and then watch the video for anything you didn't understand or to do any corrections and just to check your answers. Roaming the halls. So we have a graph here. We have 4 people, Daniel, Roberto, Jose, and Pablo, and their graphs and them wandering through the halls. So it asks a series of questions to analyze if you understand reading this graph. So who had the fastest speed? So the way to figure out the fastest speed is just a matter of who has the steepest slope. So if you look at all these slopes, regardless whether they're positive or negative, which one's the steepest? Is Daniel. Daniel, because he had the steepest slope. All right? So who had the slowest speed? Well, it'd be the opposite. So the one with the least amount of slope, right there, is Pablo. Pablo had the least slope. Okay? Who never crossed paths? So what 2 people never were in the same place at the same time? Okay? So if you look at this, we have Daniel right here. He crossed paths with Jose at about 7 seconds, and he crossed paths with Pablo at about 1 second. All right? So he crossed paths with those 2. So let's look at Roberto. Roberto also crossed paths with Pablo. He crossed paths with Pablo at about 12 or 13 seconds. And he crossed paths with Jose at about 17 seconds. But if you notice, these 2, Roberto and Daniel, their paths never crossed. Okay? So if their paths never crossed, that's our 2. Daniel and Roberto. Okay? Who is moving in the negative direction? Well, negative direction, the only way you can tell is based by the slope. Negative slope means negative direction, so who has negative slope? Well, again, we have Daniel and Roberto. Those 2 slopes are going downward, while the others, Pablo and Jose, are going upward. So they're not going up and down hills, they're just going the positive and negative directions. All right, how far did each person walk? So let's look at Daniel. Daniel started at a displacement of 80 and ended at a displacement of 0. So from 80 to 0, Daniel walked 80 meters. Roberto started at 100, but he ended right here, which is between 40 and 60. So he ended at 50. So 100 minus 50, Roberto walked 50 meters. Jose, Jose, right here, started at 0 meters and ended at 100 meters. So from 0 to 100, Jose went 100 meters. And Pablo, all right, he started right here between the 60 and the 80. So he started at 70, and he ended at 80, so he only went 10 meters. So calculate Jose's speed using the formula slope is rise over run. So, Jose. Looking at Jose. Here we got Jose. So we're going to pick 2 points. We'll pick the 0, 0, and we'll pick the 4, 10. 40, 10. Okay? So, slope is equal to rise over run. The rise is going from 0 to 40 to get to that, from this point to that point, from 0 to 40. The rise was 40 meters. The run from this point to that point went from 0 to 10. So 0 to 10, it increased by 10 units, being seconds. All right, now, so in your calculator, 40 divided by 10, you'll get 4 meters per second. So the slope for Jose is 4 meters per second. Now the interesting thing with slope is that you can pick any 2 points along the slope and do that comparison, you get the same answer. So if I were to take, let's say, that point right here and this point right here, okay? So from 20 to 60, my rise, 20 to 60 increased by 40, and then from 5 to 15 increased by 10, you still get the 40 divided by 10, you still get a 4 meters per second. All right, now let's calculate Jose's speed using the formula velocity equals displacement over time. Well, okay, so velocity is the displacement divided by the change in time. Jose displaced from 0 all the way to 100. His displacement was 100 meters. The time it took Jose to get to the 100 meters is 25 seconds. So from 0 to 25 seconds, his time, the time it took to get from the 0 to 100 meters was 25 seconds. 100 divided by 25, when you do that in your calculator, you get 4 meters per second. Okay? Now, compare those answers. So question number 6 and question number 7. Both of them, we got the answer 4 meters per second squared. They're the same. So comparing the answer for 6 and 7, well, they're the same. So what is the relationship between the slope in a displacement versus time graph and the velocity? So we're looking at this relationship between the slope and the velocity. Well, the slope, the velocity, they're the same thing. The slope is the velocity. But specifically, we have to be very careful. It's the slope in a displacement versus time graph. Okay? Because in a velocity versus time graph, which you'll get to later, it's going to be different. So there you go.